In the driest, hottest place in North America, a boulder about the size of a microwave sits at the end of a groove it seems to have carved through solid, cracked clay. The groove runs for over 200 meters, curving gently, snapping into a sharp turn, then straightening out again. No footprints, no tire tracks, no rope. For nearly a century, everyone who found a trail like this in Death Valley's Racetrack, Playa, left without ever seeing a single stone move. So what is dragging boulders that can weigh over 300 kilograms across a flat, silent lakebed while nobody is watching? And why did it take from 1915 until 2013 for anyone to catch it happening? Racetrack Playa sits inside a closed desert basin with no outlet, so rain here has nowhere to go but soak in or evaporate, leaving behind a lakebed of hardened mud about 4.8 kilometers long, close to 3 miles. At its northern end, a dark island of rock called the Grandstand rises about 20 meters out of the flat expanse. The playa is almost perfectly level, sloping only a few centimeters across more than 4 kilometers of ground. And that extreme flatness is why a breeze you could barely feel on your face is enough to move a boulder the weight of a small refrigerator. The stones tumble down from the surrounding cliffs through ordinary erosion. Roughly 9 in 10 are dolomite, the rest mostly quartz monzonite broken from the grandstand, though a few researchers describe an additional minority as syenite or granite from nearby ranges. Each one is part of a fragile, irreplaceable record, and every time a visitor drags one off its track, that record is gone for good. People have puzzled over these trails for more than 100 years. The first documented sighting came in 1915 from a prospector named Joseph Crook, out scouting for minerals. It took until 1948 for geologists Jim McAllister and Alan Agnew to bring the phenomenon into the scientific record, proposing that dust devils dragged the rocks across rain-slicked mud. A few years later, another geologist landed a small aircraft on the wet playa and used its propeller to blast the surface with wind, strong enough to flip a rock over, but nowhere near enough to explain trails hundreds of meters long. So attention shifted to ice. In 1955, geologist George Stanley proposed that stones might be locked together inside enormous frozen rafts. Starting in 1968, Caltech geologist Robert Sharp and colleague Dwight Carey spent 7 years testing that idea, labeling about 30 stones with women's names, including a 320-kilogram giant called Karen, and staking a corral around one rock to see if a rigid ice sheet would snag on the barrier. The stones slipped out anyway. In the 1990s, Hampshire College professor John Reed found trails from separate stones matching each other for hundreds of meters, hinting at ice sheets up to 800 meters across. Then, in 1996, geologist Paula Messina walked the playa's entire perimeter with a global positioning system, or GPS, receiver, and mapped its tracks with a precision nobody had managed before. Most trails, her map showed, were not parallel at all. If one giant, rigid sheet of ice were shoving dozens of rocks in lockstep, their paths should have matched. They did not. So if it was not wind alone, and it was not one giant frozen raft, what was actually pushing these boulders? The answer came from a kitchen table. In 2006, planetary scientist Ralph Lorenz was in Death Valley studying dust devils as a stand-in for weather on Mars when the sailing stones caught his attention. He had read that floating ice pushes boulders onto Arctic beaches, so he froze a small rock in about an inch of water inside a plastic container, flipped the resulting ice slab into a tray of sand and water, and blew on it. The rock skated across, cutting a trail through the sand exactly like the ones on the Playa. Lorenz published the idea formally in 2011, but it took another team, working outdoors under real desert skies, to prove it was actually happening. That team was led by paleobiologist Richard Norris and his cousin, engineer James Norris, who in 2011 founded what they half-jokingly called the Slithering Stones Research Initiative. They fitted 15 rocks with motion-triggered GPS units, installed a weather station sensitive enough to catch wind gusts once every second, and settled in for what they expected to be a 5 or 10-year wait. They got lucky in 2. In December of 2013, winter storms filled the southern Playa with a shallow pond, no more than about 7 centimeters deep. Overnight, freezing air turned its surface into ice only 3 to 6 millimeters thick, thin enough to see light through, like a window pane. On December 20th, more than 60 rocks moved at once. The next day, right around midday, researchers heard the whole frozen pond crackle and pop as sunlight warmed the ice past its breaking point. It shattered into large floating panels, and a light wind, only about 4 to 5 meters per second, roughly 10 miles an hour, caught those panels and pushed the rocks in front of them across the slick mud. The ice never lifted the stones. It did not need to. Its buoyancy simply cut the friction low enough that a barely noticeable breeze could shove a 320-kilogram boulder along at 2 to 5 meters a minute, slow enough that crossing a football field could take over an hour. Some instrumented rocks traveled as far as 224 meters, about 735 feet, and researchers realized many ghostly trails with no rock at the end or never evidence of theft, just grounded ice panels gouging the mud before melting away. If a mystery this patient can still surprise trained scientists, it is worth sticking around for what comes next. So subscribe if you do not want to miss it. A similar playa east of Scotty's Castle in Nevada, called Little Bonnie Claire, shows the same kind of trails under nearly identical conditions. Nearby, at Alkali Flat, the driving force is different. Movement there seems powered mainly by runoff rather than ice. And the idea that started Lorenz down this path came from the Arctic, where floating sea ice carries boulders onto tidal beaches, stacking them into natural barricades along the shore. Here is what makes a solved mystery feel urgent again. The exact conditions these stones depend on: a pond of just the right depth, a night cold enough to freeze it paper thin, and a calm wind the next day to break that ice apart, do not happen often. And researchers, including Lorenz himself, have pointed to evidence that the freezing nights this process needs have grown less common since the 1970s as the region has warmed. A phenomenon that took a century to explain may simply be running out of the cold nights it needs to keep happening. For 100 years, people stood on that cracked, silent playa and assumed something extraordinary had to be at work. Magnetism, or some force science had not yet named. What was actually happening was almost the opposite of extraordinary. It was a handful of very ordinary things: water, cold, sunlight, and a gentle breeze, arriving in exactly the right order, in exactly the right amounts, at exactly the right moment. The mystery was never really about whether rocks could move on their own. It was about how rarely the world lines up its smallest details perfectly enough to make the impossible happen right in front of us, if we are patient enough and lucky enough to be standing there when it does.